Hello again, everyone. In this video lesson, we are going to cover the final investment appraisal method, which we need to cover within our module internal rate of return. Strictly speaking, there are several definitions of this particular concept. The textbook definition says that the internal rate of return, or IRR, of the investment project is the discount rate or cost of capital or the required rate of return which produces a net present value equal to zero. In other words, it's a rate of return which makes net present value equal to zero. IRR is directly related to net present value. It also uses discounted cash flows for calculations. And net present value varies with the discount rate chosen. The higher the discount rate, the lower net present value of future cash flows is going to be. The lower the discount rate, the higher net present value is going to be. And there must be some discount rate which makes net present value just equal to zero. This is the internal rate of return. This definition, strictly speaking, is not particularly intuitive and not very easy to understand. In simple words, the actual meaning of IRR is that it's the actual annualized rate of return which you are earning while your money is invested in a specific project. How much do you actually make on your money? That's the internal rate of return. There are several methods which you can use to calculate the internal rate of return. The first one relies on the definition. It tells us that the net present value should be equal to zero. So what we do, we take the formula for net present value. This is the formula used in our previous lectures, and we equalize it to zero. In other words, we set up the net present value equation. All cash flows, cash outflows, and discounted cash flows for each future period, we make it equal to zero. We populate it with numbers from our project. We plug in the values for each expected cash flow, which we forecast for a particular period, plug in the number of years, and we then solve it in order to find this unknown R. We won't know the R, we won't know the rate of return or discount rate. This is what we are trying to find. It might sound complex, but in fact it's not that difficult. Let me show you an example. Let's imagine that we plan to purchase an investment property. We can buy it today at £500 and resell later at £685,000 in 3 years' time. Alternatively, we can invest our money elsewhere and earn 7% return. This is going to be our discount rate. The question is, what is the internal rate of return from this particular investment opportunity? And should we undertake it? Let's have a look. Let's lay out our cash flows and calculate the net present value of this particular project. I always recommend structuring your data in a clear way. So here we have a number of cash flows at different time periods. Initially, we make our investment. This is our initial outlay. There are no cash flows in year 1 or year 2, and there is a single cash flow in year 3 when we sell our property. In some other cases and some other situations, you might be getting cash flows during the interim period between purchase and your sale. For example, if you rent out this property and you get rental income. What you need to do, you add up all of the cash flows for each particular period in order to calculate the total. Then, when you calculate net present value, you discount each cash flow using a relevant discount factor. For example, this first £500,000, our initial investment, was not discounted because it's expressed in present terms already. In our denominator, we use power 0, which will make the whole term just equal to 500,000 with a negative sign. There are no cash flows in period 1 and 2, and the final cash flow is discounted using this discount factor. This is what we've done to calculate net present value, and what we need to do now, we are just replacing our 7% discount rate with the unknown internal rate of return, and we equalize net present value and make it equal to 0. We set this number equal to 0. Now what we can do, we simply solve this equation. It's an equation with a single unknown. We can do it manually, or we can do it in Excel. There is an Excel formula which allows us to do it quickly and easily. Calculating internal rate of return using Excel is beyond your syllabus. However, there is a separate presentation with a voiceover which explains how to do it. It's optional. If you want, you can have a look at it. It's available on Moodle. I explained there how you can do it using Excel. The result of this particular calculation happens to be 11%, 11.06%. What does this number mean? It means that while our money is invested in this particular project, when we buy this particular property, we receive 11% return. Alternatively, if we deposit the original amount, £500,000, elsewhere at this particular rate of return, for example, we put it in a bank account which generates this return 11%, we will also have the same amount, £685,000 at the end of year 3. This is how much money we make while we're invested in this project. This is its internal rate of return. Second method, which you're probably going to use more frequently, it's also called a linear interpolation method. It will give you an approximate number. However, it's easier to do if you don't want to use Excel. This method uses a specific formula which allows us to compare net present value at high and low discount rates. This method relies on this particular graph. It shows that as discount rate increases, net present value declines. The higher the discount rate, the more we discount future cash flows, and as a result, net present value becomes lower. And in reality, if the discount rate is very high, the net present value can become even negative because future cash flows, if we receive them in a distant future, they're discounted so much that they don't bring significant value in present terms. And as a result, net present value can become negative. And internal rate of return, by definition, it's a point, it's a discount rate, which makes net present value equal to 0. In other words, it's a point where net present value line turns from positive to negative. So this is our internal rate of return. This is the actual formula. Again, it might sound complex. I'll explain how do you apply it. What are the steps when calculating IRR using this formula? First of all, we need to choose two discount rates. One low rate, which will make net present value positive, and another discount rate, high discount rate, which will make it negative. We'll calculate net present values, the location of points on this curve, at each discount rate, and plug everything which we've calculated into this particular formula. Our result is going to be approximate. It will rely on approximation of the shape of the curve between 2 points which we've calculated. So the result will not be exactly accurate, but it will give you a rough idea of what your IRR is. Let's see how we can calculate the internal rate of return for the following project. The project lasts for 4 years. Initially, we invest £80,000 and it will generate a certain set of cash flows in the next 4 years. So how can we find the internal rate of return for this project? First of all, we'll need to select some discount rates. One discount rate will be a low discount rate, let's say 5%, and we will need to calculate the net present value at this 5%, at this low chosen discount rate. And also we'll need to find some higher discount rate, let's call it RH, higher discount rate. And similarly, we calculate the net present value at this particular discount rate, the net present value of this project. Let's say this could be 10%. Ideally, we need to select discount rates in such a way that at the low discount rate, net present value is positive, and at the high discount rate, it is negative, because we're trying to identify this intersection. We're trying to find the area where net present value turns from positive to negative. So we need to be located somewhere there. Let's calculate our present values. At 5%, the present value of each cash flow is shown here in the third column, and present value of each cash flow at 10% discount rate is shown in the last column. And if we add up all of these cash flows, we will get net present value, the location of 2 hour points. So let's add this data to our diagram. Our net present value is equal to 6,685 if we choose 5% discount rate, or it's actually equal to minus £425 if discount rate is equal to 10%. We can see that our net present value changes sign, in other words, turns from positive to negative somewhere between 5 and 10%. In other words, our internal rate of return is somewhere within this area, between 5 and 10. Probably closer to 10 because this value is closer to 0 compared to 6,000. So maybe 9% or something like this. In order to find the approximate number, we simply plug in the values which we've used in our calculation into the formula. Chosen rate of return is 5%. Net present value calculated at this low rate of return is 6,685. The denominator again uses the same figure, and we need to subtract net present value calculated at the high interest rate, in other words, minus 425. Minus and minus will give us a plus, so we have a plus 425 here in the denominator. And we also need to multiply by the difference between high and low chosen interest rates, 10 minus 5%. If we make these calculations, we will end up with the number 9.7%. As I said, it's somewhere between 5 and 10, but closer to 10. So this is an approximate internal rate of return generated by this particular project. When you invest your £80,000 into this particular asset, you are earning 9.7% return on your investment. This method is probably easier to implement, and this is the technique which we will use in our seminars as well. Let's have a look at the investment decision rules, which are based on the internal rate of return. We are studying all of these metrics in order to be able to make investment decisions, in order to be able to appraise certain investment opportunities and decide whether we should invest or not. And if we have several opportunities, to be able to compare and choose the best one. How do we make an investment decision? First of all, we should only accept an investment project if it generates an internal rate of return greater than your discount rate. Let me remind you what the discount rate is. This is the rate of return which you can reasonably expect to get in a comparable investment by investing a similar sum of money with a similar risk. In other words, if the rate of return which you earn in this project exceeds the rate which you can earn elsewhere, you should invest. Your wealth will increase as a result of it. However, here I've also included the idea of cost of capital and target rate of return, because your discount rate can also be treated differently as a cost of capital. Just have a look. If your internal rate of return from a project is greater than the cost of capital, your wealth will increase. For example, you borrow money at 5%, you invest them in this project, and it generates a return of 15%, which means that you can keep this 10% difference. You've borrowed money at a low interest, you've invested them, and you get a greater return. Follow this rule. If IRR exceeds your cost of capital, your wealth will increase. You should accept this project. Alternatively, you can also compare internal rate of return with your target rate. For example, your company only wants to pursue projects which generate at least 20% return. In this case, if IRR of a specific project is greater, go for it. You also need to know that the higher the internal rate of return, the better, because apparently it's always beneficial to earn higher profit rather than lower profit. And if you have several investment opportunities which are mutually exclusive, you should select the project with the highest internal rate of return. However, there might be some conflicts between signals generated by internal rate of return and other investment appraisal metrics, especially net present value. If you happen to be in a situation when internal rate of return is higher for project 1, but net present value is high in project 2, you should go for project 2, because net present value is more important as a decision-making criteria, because it explicitly shows how an investor's wealth will increase as a result of this particular project, of this particular investment. In other words, when internal rate of return and net present value give conflicting signals, you need to select the project with the highest net present value, ignoring the percentage rate of return. I will give you a short example to illustrate this, and on Moodle you will be able to find a detailed explanation with 2 investment properties, again with figures and everything. I've explained it really well. If you want, you can have a look. Apart from this, net present value is also preferable when project's cash flows are non-conventional. We'll cover this in the next few slides. And net present value is preferable when discount rate changes during the project's life. In all cases like this, you would really not pay too much attention to the internal rate of return metric and focus instead on the net present value you've calculated. This is going to be more important. Let's have a look at the examples. Let's imagine that we're considering 3 potential investment projects, A, B, and C. In each case, you invest £5,000. The projects will last for 7 years and they will generate different streams of cash flows. If your cost of capital is 10%, which product should be selected? If you use IRR or if you use net present value? Let's have a look. If we calculate these figures for all investment projects, we will be able to see that net present value is the highest for project B, £621, rather than 200 or 350, and its internal rate of return is also the highest, 13.9%, rather than 12 or 12.3. So project B is apparently more attractive than other projects. So if the projects are independent, if you've got enough money to invest in all three, you should accept all three, because they all generate positive net present value. This is our first decision-making rule, which we've covered already in a previous lecture. And also because their internal rate of return is greater than the discount rate and your cost of capital. You can borrow money to invest in these projects at 10%, and you can generate higher return and keep the difference. Because of all of this, there is no conflict between net present value and internal rate of return. They both suggest that you should invest. You should invest in all three projects if you can. And if you can't, if these projects are mutually exclusive, if you only have, let's say, £5,000, or if your company has only enough time and staff and expertise to pursue one project at a time, you should select project B because it generates higher net present value and high internal rate of return. As I mentioned previously, there might be situations when there is a conflict between net present value and internal rate of return. For example, we invest in project A, £10,000. It generates £12,000 of cash flows in the next 2 years, which makes its net present value equal to £413. At the same time, project B requires a smaller investment of £6,000 only. It will also generate certain cash flows in the next period, and it will result in a net present value of £334. In other words, if you compare these two projects using the net present value, you will see that you should go for project A, because as we know, it generates higher net present value. In other words, your wealth will increase by greater amount if you pursue project A by £413 rather than £334. So project A is preferable. However, if you calculate the internal rate of return, you will see that IRR for project B is actually higher. You are earning 14% here, while you're earning 13% only in project A. So IRR would suggest that project B is preferable, not project A. So how do you make a decision in a case like this, when there is a conflict in these signals? And as I said, net present value is more important decision-making rule, because it measures an absolute increase in shareholders' wealth. It shows how much better off you're going to be if you invest in this particular project rather than elsewhere. Because your wealth will increase by more if you select project A, you should go for it, in spite of the fact that its internal rate of return, the percentage return, is lower. What is also important here is that you invest different sums if you can pay attention to this. In project A, you earn 13% on 10,000 invested, while in project B, you earn a slightly higher percentage return, but on a lower sum. So in absolute terms, your actual additional profit made is going to be lower. Here, you invest a small amount, and in spite of the fact of the high IRR, your actual result, your actual additional cash in your bank account as a result of this investment is going to be lower. So that is why net present value is more important from the shareholders' wealth maximization point. Next, I've also mentioned that internal rate of return metric struggles with unconventional cash flows. It finds it difficult to analyze cases when the cash flow stream is not traditional. What do we mean by conventional and unconventional cash flows? A conventional cash flow is a situation when your initial outlay, the investment which you make, the negative cash outflow, is followed by a number of positive cash inflows over the period of time, over the life of the project. You invest once and you start receiving returns. For example, you buy dividend stocks. You purchase them and you start collecting dividends. There is only one change in sign in the cumulative cash flow total, from negative to positive. A project with unconventional cash flows is a situation when you have more than one cash outlay. which involves more than one change in the cash flow direction. For example, when you buy an investment property, you purchase it first, then you might need to renovate it, which will require some additional spending. Then you possibly rent it out and start receiving positive cash inflows. But in a couple of years' time, the boiler might break in your house and you might need to repair it. Or your tenants will trash the property and you will need to renovate it again. Or you might need to spend some money maintaining it regularly. So this particular project will represent an unconventional set of cash flows. The problem is, this type of unconventional cash flows, which can be positive and negative throughout the life of the project, can result in several different internal rates of return or no internal rate of return at all. Remember, in order to calculate net present value, if we have net present value along vertical axis and the discount rate along horizontal axis, we rely on the fact that net present value graph crosses horizontal axis at some point, which is our IRR. But what if our net present value looks like that? It changes all the time because of changes in cash flows. Initially it becomes positive, then it declines, then it goes up again. In this case, there might be several points where our graph crosses horizontal axis, so there might be several internal rates of return. Or our graph can be located somewhere here, which means that there is no IRR at all because there is no discount rate which will make net present value equal to zero. So generally, internal rate of return struggles with situation when our cash flows are unconventional. If you look at this table here, you can see two examples of projects with unconventional cash flows. For example, project C, which results in initial outlay, then starts bringing us some cash, then requires more investment, additional investment. In fact, this project has two internal rates of return. If you lay out the cash flows and calculate net present value, you will see that there are two solutions to this particular case. While project D, which strangely enough starts with a positive cash flow, then requires some outlay and then starts to generate cash flow again, will have no IRR at all. So quite interesting situations, and this particular metric, internal rate of return, does not really work well with these particular cases. So if we summarize pros and cons of internal rate of return as the investment appraisal method, we will know that this is one of their disadvantages because it can result in multiple or no solutions. Another disadvantage is that, unlike net present value, it ignores the relative size of our investment because it concentrates on a percentage return, but not an absolute profit which we are going to make as a result of this particular project. And it's not directly linked to shareholders' wealth maximization, again, unlike net present value. And apart from this, it also cannot cope with changes in the discount rate. It spoils all calculations completely. It makes it difficult to apply it in real life. However, like net present value, internal rate of return also represents a form of discounted cash flow analysis. In other words, it takes account of time value of money. It does recognize that cash flows obtained in the future are less valuable compared to more recent cash flows. It also includes all the relevant cash flows, unlike the payback period, for example, which only analyzes cash flows up to the break-even point in time. Here, we include all relevant cash flows into our analysis. It also helps us to maximize shareholders' wealth if we pursue all projects with an internal rate of return greater than the cost of capital. It's a good decision-making rule. If your rate of return from this project is higher than the cost of capital, you should select it. This will increase your shareholders' wealth. Quite easy to understand rule. And apart from this, if you calculate these figures, it's very easy to understand what return from a project equal to 8% is. Everyone understands this. It's quite intuitive. It uses percentage figure and it's easy to understand. To summarize, to bring everything to conclusion, this week we have studied 4 different metrics which you can use in order to appraise various investment projects. You can use them in your professional life and you can also apply to your individual personal investment decisions if you wish. And I've summarized the main decision-making rules here on this slide. First of all, first main criteria, main decision-making rule. Only invest in a project if its net present value is positive, because it shows how our wealth will increase as a result of this investment. If you need to choose between several alternative investment projects, select the one with the highest net present value. because it will allow you to maximize your wealth, to make you richer. You should only undertake a project if its internal rate of return exceeds your discount rate, in other words, the rate of return which you can earn elsewhere in an alternative investment. You should only undertake a project if its internal rate of return exceeds the cost of capital or your target rate of return. And finally, if you have a conflict in signals generated by different investment appraisal methods, go for net present value because it's more important as a decision-making parameter. That's it for this week. I do hope that you've learned a lot in this particular lecture, and I'll see you again next time. Bye-bye.